Say hi, Cece. Oh, who's a good pupper? Say hi, Cece. Say hi to all our subscribers. Troy Bravo, or Mr. B, asked me to do a video talking about the James Webb Telescope, which will be an amazing, cool video that pushes the boundaries of science communication, and will be released approximately 6 months from whatever day you're currently watching this one. Hello again, astronauts. Welcome to Bad Astra, a wacky science channel where we learn about physics with more costume changes than math. On Wednesdays, we release videos ranging from the Bad Answers series, where we answer viewer-submitted questions, to interviews with scientists about their research, to science-related music videos when we're feeling extra ambitious. Our main content comes once a month in the form of deep dives on scientific topics, from the life cycle of stars, to vaccines, to the history of the universe. Please remember to like, comment, subscribe, share, and check out our Patreon for early access to videos and exclusive content. The James Webb Space Telescope, assuming it's ever actually completed, will be an orbiting infrared observatory designed to extend NASA's observing abilities beyond the Hubble Space Telescope by covering longer wavelengths and having improved sensitivity. By detecting these longer wavelengths, this telescope will not only be able to look inside dust clouds where stars and planetary systems are forming, but see closer to the beginning of time and hunt for the yet unobserved formation of the first galaxies. Astronomers don't actually know all that much about the early universe, since our observational capabilities are limited, and pushing the boundaries of what we can see is the full-time job of multiple astronomers I've interviewed for this channel. Images of the first stars igniting, snapshots of the first galaxies coming together, planets forming around young stars and nebulae, and even analyzing atmospheres on distant exoplanets all sound really cool on their own. But they're even cooler when you think about where those observations could lead. Observations of population 3 stars, the first ever stars, we think, could confirm or change our theories about the early universe and how heavier metals like carbon and oxygen were distributed throughout the universe, so we could exist and breathe. Comparisons of early and modern galaxies could give us a better understanding of how galaxies form and evolve over time. Watching planets mid-formation could tell us a lot about how our own solar system formed and how it compares to others. Analyzing the makeup of atmospheres on other worlds could lead to us finding the building blocks of extraterrestrial life. The James Webb Telescope, if it's ever completed, could be revolutionary for the field of astronomy and how we humans see ourselves in the context of the universe. NASA, the Canadian Space Agency, the European Space Agency, and 306 contributors from North America, Europe, and South America are working together on this. It will be the most ambitious space telescope humanity has ever built. You want innovations? Webb's got lightweight optics, a deployable sun shield, a folding segmented mirror, improved detectors, cryogenic actuators and mirror control, and micro shutters. Let's talk about that primary mirror. And not just because Science Tommy loves hexagons. But check out those massive, glistening hexagons. For telescopes, size matters, and bigger is definitely better. Bigger telescopes can collect more light and resolve finer detail, so you can see fainter stuff further away. To be sensitive enough to detect and get decent resolution on the furthest possible galaxies, literally seeing back in time to the first ever galaxies, Webb's primary mirror, the main dish, has to be 6.5 meters or 21 feet 4 inches across. That's really big. I'm 5'4", so that's exactly 4 times my height. Not only is building a mirror that big difficult, but this mirror also has to be lightweight enough to be launched into space. Remember when I said this was the most ambitious telescope ever? So why is this not just the Hubble Space Telescope's 2.4 meter mirror, but bigger? Well, if the Hubble's primary mirror was scaled up to be large enough for Webb, it would be too heavy to go on the rocket. Like 10 times too heavy. Also, how would you fit a 6.5 meter diameter circle into a rocket? Would you just bungee cord it to the side and hope for cartoon physics? Probably not gonna work. So this telescope is going to be made out of beryllium, which is strong and light, with each hexagon only weighing around 20 kilograms or 46 pounds. Instead of a giant circle, the mirror will be built in 18 hexagonal segments, 1.32 meters across, that fold up to fit inside the rocket and fold out once they get to space. And they chose hexagons because hexagons are the sexiest of shapes. Just kidding. Hexagons are the regular polygon with the highest number of sides that still tessellate, or fit together like bathroom tiles. If the shapes all fit together, the telescope doesn't have any gaps, and astronomers have less post-processing hell. Using hexagons also allows the overall mirror to be roughly circular, which is the best shape for telescopes because it won't distort the image and will collect the most light. And, for that extra flash of glitz, the hexagonal mirrors are all covered with a microscopically thin layer of gold. The scientists say this optimizes them for reflecting infrared light, but we all know it's because NASA wanted to flex. Unfortunately, although the initial launch date was scheduled for 2007 and the telescope was proposed back in the late 90s, there have been a few minor delays. It's become a running joke whether this telescope will ever be launched, given how delayed and over budget it's gotten. But as of recording, the James Webb Telescope is scheduled for launch at the end of October 2021. And tests appear to be going well? Given the past hell years we've had, I'd say we deserve a win. So I'm going to choose optimism and say I look forward to the successful launch of the James Webb Telescope. 6 months from whenever you're watching this video. Astra out.
Ad Astra, to the stars, to the stars.